I'm not as think as I smart I am. I'm not as think as I smart I am. I'm not as think as I thought I might be, for that's clear anybody to see. I'm not as think as I smart I am. I'm not as think as I smart I am. I'm not as think as I clever I would be. I'm not half as clever as me.
Hi, I'm your host, The Ordinary Guy. Welcome to the second episode of the Brains Matter podcast. The podcast will bring you stories on astronomy, chemistry, physics, biology, humanities, left-of-centre knowledge, and anything else that's interesting. Thank you to everyone who's given feedback so far. I'll be taking that all on board, and hopefully the show will improve as time goes on. There have been some really interesting stories in the world of news in the past couple of weeks. Firstly, BBC News have reported that some scientists in Israel have discovered that facial expressions are hereditary, and they say that children inherit their facial expressions from their parents, and most notably their mother. And the way they actually did this experiment was that they got some kids who've been blind since birth, so therefore there was no influence from the way they viewed their parents' expressions at all, because they would have, of course, never have seen it. So what they did is they got these kids, and what they did is they surprised them, they did things to make them happy, they did things to make them sad, and then photographed their expressions during this time, and then compared it to photographs of their parents, and they found there was a striking resemblance between the kids and their mothers. And one of the scientists who did this said, and I quote, "We have found that facial expressions are typical to families, a kind of facial expression signature." And this is interesting because this was a theory that Charles Darwin proposed in 1872 as part of his whole evolution idea. So it leads some more credence to the whole theory of evolution, if you want to call it a theory, or if you consider it to be a fact. There's so many things now that seem to point to evolution actually being a fact, apart from all of the fossils and the research that have been going on in that space as well. And for those of you who are fans of physics and chemistry, news has come in that researchers have discovered element number 118. Back in 1999, nuclear physicists at the Lawrence Berkeley National Laboratory in America claimed to have found element number 118. They claimed they created it for a very small fraction of a second during some experiments, but then it turned out that some of the data they'd used for that particular experiment was forged. Shame on them. Kind of reminds me of the heavy water and cold fusion claims from several years ago. But just last year, in June 2005, scientists from the Joint Institute for Nuclear Research in Dubna, Russia, have announced that they've discovered element 118, and as a byproduct, element 116 as well. Element 118 is the last one in a series of superheavy elements produced in nuclear reaction with calcium-48, says Dubna team leader Yuri Oganessian. So far, all the experimental data point to the existence of an island of stability in the region of superheavy elements, as theory says it should. So the Livermore and Dubna collaboration between these two groups of scientists have produced, in the last several years, elements 113, 114, 115, 116, and 118. And over the next couple of years, they plan on trying to create, for a very small fractions of a millisecond, element 120 by bombarding a plutonium target with iron isotopes. Now, it's kind of interesting that we've found 118, or soon to be, hopefully, 120 elements existing in nature as we know it. There's about 90 elements that occur naturally, and the rest of them are created artificially in laboratories or as byproducts of other nuclear or chain reactions. But a curious thing that I was talking to someone about quite a while ago was that the ancient Vedic cultures, they have actually commented on the fact that in their ancient scriptures, which are several thousand years old, they mention 105 stable elements. And keep in mind, this is several thousand years ago, and Western science talked about there being four main elements, which is earth, wind, fire and water, for many years, and this was years and years before J.J. Thomson, which was at the turn of the 20th century. And we've only been going down this path of elements and stable elements and protons and neutrons and so forth over the past 50 years or so. And our understanding of it is relatively recent. So the question comes in, is this knowledge something new? Is this knowledge something that humans have known previously in the past? There's a lot of open-ended questions there. And I'll just leave that for you guys, the listeners, to think about and do your own research upon. And if you have any comments about that, or if you find anything interesting, feel free to drop me a line at brainsmatterinbox@gmail.com. Another story that the media seems to have picked up on is the invisibility cloak, especially for those who are fans of Harry Potter and stories like that. Scientists at Duke University over in the US have been able to create what they've called a cloak of invisibility in the laboratory. And it basically works by deflecting microwaves around a small cylinder and making those microwaves reform around the other side of it, so that a detector at the other end doesn't notice that there's an object in between. And the easiest way to think about this is to think of a river. If you're standing in the river and there's a rock ahead of you and the water's flowing towards the rock, you will see it because you're close enough to the rock, and you will see the after effects of it because the waves of the water have gone around you. If, however, you're another 500 meters downstream, you will never know that there was a rock in the middle of the river, because the waves of the water reform around the edge of the rock and then continue on downstream as if it had nothing in between at all. And that's exactly what's happening with this particular experiment here with the copper cylinder using the microwaves. So somehow they've created enough interference around the fiberglass rings with the copper elements to be able to reform the microwaves as a continuous wave after the ring. So it appears from a distance that there's nothing there to start with. So it'll be interesting to see where this leads. I don't think you'll be able to have an invisible cloak, despite what all of the romantic notions of that might be. But it may lead on to other things, because the great thing about science is that a lot of experiments and a lot of discoveries lead on to other things which you would never have thought of in the first place. There's also been a report about the sun dimming, and this was first spotted by Jerry Stanhill, who was an English scientist. And what he discovered was that the amount of solar energy reaching the Earth's surface has been falling over the years. He compared sunlight records from the 1950s to the current records that we have, and he discovered there was a huge fall in the amount of solar radiation that was reaching the Earth, to the effect of about a 22% drop in the amount of sunlight. And he calls it global dimming, and a lot of scientists thought, I don't know if this is really true, but it was confirmed recently by some Australian scientists using a completely different method to work out the amount of solar radiation that the Earth's receiving. And what they discovered was that solar dimming appears to be caused by air pollution, and this generally comes in the forms of burning coal, oil, wood, usage of cars, power stations, cooking fires, and carbon dioxide. And carbon dioxide, as we all know, is the principal gas responsible for global warming. The research also shows that this makes them more reflective than they otherwise would be, and this in turn reflects the sun rays back into space. And one of the after effects of this is that it actually causes changes in global climate, apart from the effect of the carbon dioxide by itself. And what the researchers also discovered is that the global dimming has probably led scientists to underestimate the true power of the greenhouse effect. They know how much extra energy is being trapped in the Earth's atmosphere by carbon dioxide, But what they haven't kept in mind is that there's extra energy that's resulted in a temperature rise of 0.6 of a degree Celsius, and that's led scientists to conclude that the present-day climate is less sensitive to the effects of carbon dioxide than it was during the Ice Age. So what in effect has been happening is that the global dimming has been cooling temperatures, carbon dioxide has been increasing temperatures, so they've been cancelling each other out, but the net effect of that is that the climate is more sensitive to the greenhouse effect than previously thought. And so, according to Dr. Peter Cox, who's an expert in this area, this is extremely bad news. He's one of the world's leading climate modelers. So that's something that the politicians probably should take a note of, apart from all the other bits and pieces they've been told from scientists over the past few years. Okay, now it's time for today's brain teaser. And today's brain teaser is: which famous European landmark has 1,665 steps? The answer to this later in the show.
5 minutes into the future, that's where you will find me. 5 minutes into the future is a wondrous place to be.
And that song was 5 Minutes Into the Future by the Socknockers. 5 minutes into the future. How about 5 minutes from the past? Time travel is something that's always been of interest to humans, whether it be from your Star Trek TV shows, Quantum Leap, Back to the Future, any of these types of stories. I know there's a lot of people out there, a lot of kids, a lot of us growing up watched these kind of shows and enjoyed them, and most of us probably sit there and think, it's just stories, it's just novels, it's just movies, it's just TV shows. It'll never happen. But it does. When you look outside every night, you are travelling in time, because when you look up at a star, that is how the star appeared many, many years ago. So if you think about it, if a star is, say, 10 light years away, for example, then what that means is that the light from that star takes 10 years to leave the surface of that star and then come out and reach our eyes. The way light works is that it doesn't come out from our eyes itself, but what happens is that it has to get reflected off the surface. So an energy source like a star or our sun will release this energy in the form of photons or light waves and reach us at the speed of light, which is 3 times 10 to the 8 meters per second. So what does that mean? So that means if you were standing on the surface of the star that's 10 light years away, it would be 10 years before that light that you saw when you were standing on that star reached the Earth. So when I look up into the sky and I see that star that is 10 light years away, I'm seeing that star as it appeared 10 years ago. For all intents and purposes, that star may not exist anymore. It might have exploded in a supernova. But I won't know that for another 10 years because the light from that explosion won't reach the Earth for another 10 years. So if you look at even more distant objects, so things that are 100 light years away, 1,000 light years away, 1,000,000 light years away, you're looking at those objects as they appeared that far back in time. So when you look up into the sky, you're probably looking at many, many stars as they were when dinosaurs roamed the Earth, or perhaps sometimes stars that may have existed even before the Earth was formed. So you are participating in time travel, and it reminds me of a quote from Yahoo's series in the movie Young Einstein, and the quote went something along the lines of this. He was talking about a clock and time travel, and he was saying, looking at the clock and saying, light travels to us from that clock at the speed of light. Now, if I moved away from that clock at the speed of light, the hands of the clock would appear to have stopped. Time would stand still. This moment would last forever. And that is exactly right in terms of explaining the speed of light and time. If you were travelling away from a clock with ticking hands at the speed of light, you would never see it tick, because if you were going away at the speed of light, the light that was catching up to you would be exactly what had left the clock when you left the clock. So it would appear to you that the clock had stopped. Now, if somehow you could go faster than the speed of light, it would actually appear that the clock was going backwards, so you'd be going backwards in time. But can you do that? Is it possible? I don't know. Maybe a physicist out there who's an expert in theoretical physics can show some of the rest of us the mathematics around it, but as far as we know at the moment, that's not possible. But speaking of such things, there's been some news in the press lately about two galaxies colliding. There was a smaller galaxy that collided into the Andromeda galaxy that's been seen recently from Earth, and the cosmic crash was believed to have happened about 210 million years ago. So effectively, if you look in your telescope or your set of binoculars to have a look at that, you're seeing what happened 210 million years ago. How does Andromeda look today? I don't know. We won't know for another 210 million years. But also keep in mind, Andromeda is the closest galaxy to the Milky Way. And now it's time for the answer to today's brain teaser. So which European landmark has 1,665 steps? It is, of course, the Eiffel Tower in Paris. It was built in 1889 and is completely repainted every 7 years, and it takes 25 painters 15 months to repaint it using brushes. They do it all manually. They use 60 tons of paint. I wonder if Gustav Eiffel thought about how long it would take to paint when he designed the thing. So thank you for listening to the Brains Matter podcast. It's been the second episode. If you have any questions or suggestions, please drop me an email at brainsmatterinbox@gmail.com or leave a comment on the website, which is at www.brainsmatter.com. And please let me know where in the world you live and how you found the podcast. Music used on today's show comes courtesy of the Podsafe audio network. You can find the podcast by doing a search within iTunes or subscribing manually at feeds.feedburner.com/brainsmatter with a capital B and a capital M. And before I go, I'll leave you with a quote from Friedrich Nietzsche. The advantage of a bad memory is that one enjoys several times the same good things for the first time. I hope you enjoyed the show. Bye bye for now.
I smart, I was thought, but I know I am not. Crow, I now know I'm eating like pie, an arrogant idiot high. I'm not as think as I smart, I am. I'm not as think as I smart, I am. I'm not as think as I thought I might be, for that's clear anybody to see.